Rotations. A rotation is a transformation in a plane in which a figure turns around a fixed point. The fixed point is called the center of rotation, and the amount of turn is called the angle of rotation. In this example, it's 90 degrees. So if we start off with point F, for example, and we draw a line to the center of rotation, and we're rotating at 90 degrees, we're going to actually have an opposite reciprocal slope in the counterclockwise direction. So we had to go down 1, 2, 3, 4, 5, 6, 7, and to the left, -1. So that means the slope originally from point F to the center of rotation is -7 over -1, or a +7 slope. So therefore, from the center of rotation, I'm going to end up having an opposite reciprocal slope. So instead of having 7 over 1, I'm going to have -1/7. And since we're going counterclockwise, the negative sign is actually going to go with my run value. So I'm going to go up 1, positive, and then to the left 7. 1, 2, 3, 4, 5, 6, 7. And that's how I find the coordinates of f prime. We can do something similar for d to d prime. We can count to get to the center of rotation. We're going to go down 1, 2, 3, and to the left 3. So the slope here in this case is -3 over -3, or +1 over 1. And then to get to d prime, I'm going to have the opposite reciprocal slope, which is going to be positive. It's going to be +1 and a -1. So a -1 slope. And because of the orientation, we're going to go up 3 and to the left 3. So we went +3 and -3. So a way to get from each point to the center of rotation is to think about slope with rise and run, and then do the opposite reciprocal of that to get to the new point for your image. You could also use concentric dashed circles that are centered at the center of rotation to serve as an aid. On this slide, we have another rotation shown. It still has a center of rotation and the angle of rotation. This time the angle is 180 degrees. And 180 degrees is a straight angle or a straight line. So in order to get from a pre-image point to the center of rotation to the image, you can generally count the same number of points and in the same direction, and the slopes will match. Because again, a 180 degree rotation is a straight angle and creates a straight line. So for example, from point F to the center of rotation, we're going to have to go down 1, 2, 3, 4, 5, 6, 7, and to the left 1. So the slope to get there is -7 over -1. It does reduce to a +7, or 7 over 1. But this original one that we have also tells us that if we follow the same exact movements in those same directions, we're going to get to the image point. So we're going to go down 7 again. 1, 2, 3, 4, 5, 6, 7, and to the left 1. And the leftward direction is negative. So you can use the original slope and use it again to get from the center of rotation to the image point. Let's do another one. Let's look at point D. So for point D, to get to the center of rotation, we're going to go down 1, 2, 3, and to the left 3. 1, 2, 3. So the slope here is -3 over -3, which does reduce to 1 as a slope. So the slope is still going to be 1, but we have to again go down 3 and to the left 3, 1, 2, 3, to get to d prime. A rotation preserves both distances and angles. Therefore, like translations and reflections, a rotation is a rigid transformation. The following are properties of rotations. We know that polygon ABCDEF is congruent to polygon A prime, B prime, C prime, D prime, E prime, F prime. We know that AB is going to be equal to A prime, B prime, and that BC is going to be congruent to B prime, C prime, etc. Similarly, the distance between each point and the point of rotation will be equivalent to the distance from the point of rotation to the image point. So the distance from A to P is equal to the distance from A prime to P, and from B to P is going to be equivalent to B prime to P, etc. And then the angle created from A to P to A prime will be our angle of rotation, theta, in this case 45 degrees. Similarly, angle B to P to B prime will also be theta, and again in our case it's 45 degrees. If we look at C to P to C prime, that will also create a 45 degree angle. Same with D to P to D prime, that'll be 45 degrees, and so on. And the angle of rotation, as long as it is positive, coincides with a counterclockwise rotation. A rotation can be counterclockwise or clockwise. A counterclockwise rotation coincides with positive values of the angle theta, and clockwise rotations coincide with negative values of theta. So in this diagram, we have our pre-image and our image, and the angle of rotation this time is negative 45 degrees because it's 45 degrees in the clockwise direction. Here's a link to some interactive graphics that we can explore rotations with. So if I click on this link or this link here, they both lead to the same thing. So here's the activity. What's kind of neat is you can actually take the center point MN and move it to wherever you wanted it to be. So right now I have it at the origin. And then we can change the degree of rotation. Right now it's at negative 180. So if I bring it back to 0, where it originally started, okay, negative is going clockwise, and positive is going counterclockwise or anti-clockwise. And we can see where the points end up lying when we get to different degree values. The figure to the left shows an anti-clockwise, or otherwise known as counterclockwise, rotation of x degrees about point P. So we see our original pre-image or object is A, B, C, D, E, F, and then our image after the x degrees rotation anti-clockwise is going to be A prime, B prime, C prime, D prime, E prime, F prime. A counterclockwise rotation of x degrees about point P is written as lowercase r. Remember, capital R was a reflection, so this lowercase r signifies rotation. And then in parentheses and in subscript, we have x degrees, comma, P, our point of rotation. In this case, since the rotation is counterclockwise, x is greater than 0. And the rotation of x degrees about point P of polygon ABCDEF gives us polygon A prime, B prime, C prime, D prime, E prime, F prime. The angle of rotation applies to the corresponding angles as shown, and the distances from P to the paired points, and those are equal. So from this point to P, we're going to travel that same distance from P to our new point by that same angle. So if I also were to draw I'll draw it in green so that it's a little bit different. From this point up here, straight down to point P, and then I'm going to travel that same distance up to the image point right here. And this angle is again going to be X degrees. You're going to take every single point that you have in your polygon and you're going to rotate each of those points X degrees by the point of rotation. An anti-clockwise or counterclockwise rotation of X degrees about point P is shown in the first picture to the left. Since the rotation is anti-clockwise, our X value, or the degrees of rotation, is greater than 0 or is positive. A clockwise rotation of X degrees about point P is shown in the second picture to the left. Since the rotation is clockwise, our X value, or the degrees of our rotation, will be less than 0 or negative. And that's why we have it noted in here as negative X degrees.